Hiya! So in this video, we're going to be looking at what happens if our change in variable isn't just an increasing or decreasing function, if there's some kind of waviness to it, like something that increases, decreases. And basically, we're just going to take the super dumb approach and say, well, just break it up into the increasing and decreasing parts and put them all together. That's basically it. So in other words, if I have some function like this, right? What this is saying is look at each individual portion where it's increasing and decreasing and apply our formula from before in this way. So in other words, this would be one interval here. This is another one. And this is another one, kind of. So these are our like kind of three intervals for this one. And this is what this summation is basically saying. Grab all of the sum over all the x such that g of x is equal to y. So basically everything like within some little grouping and put them all together. So let's kind of see what I kind of mean in this way. Because this probably looks really bizarre, and I would agree. It's super bizarre notation. So it's literally best done through an example to kind of see what I mean. And then I can explain it a little further in Monday update or in a class if it's still a little confusing. So here we're going to take x be some random variable. I don't really care. And, oh my god, these notes are bad. And let y be x of x squared. So here our function is x squared. So in other words, we're looking at something that decreases and then increases. Here, I didn't give you a range, and basically what I'm just assuming is the range is everything. And so since the range here, so basically range goes from minus infinity to infinity, and this gets converted to, well, if you look at this, it goes to 0 to infinity. So it's changing y from 0 to infinity. So this is our range. And so next, let's actually calculate the derivative, which is what we've been doing, right? So if I calculate the derivative, y is equal to x squared, I get dy is equal to 2x dx. Here, let me see what my x is. If I take the square root, I get x, right? So I really have dy over dx is equal to 2 times the square root of y. But here, notice how my y can be plus or minus, right? Because x can either be a positive number or it can be a negative number. So really, I have two options for my dy. There's two different things I can kind of do here. And this is where I'm saying we have the two different ways of looking at this. So when I do my summation, f of y, I want to sum over... let me write this down slowly so we can kind of see what happens. All the x such that g of x is equal to y. F of x and then dy dx. So notice how we have two different versions of y, right? So what this means is I have to look at the summation of all the different options. So I have x... like this is our two different options, right? So I have x is either going to be plus or minus y. This is the set, the two summations, right? So this is our two possibilities, plus or minus y. And so f of x over dy dx. In other words, we're going to look at all the sum from all the x such that x is equal to the square root of y. And in this case, what we have is, so f of x, I guess I didn't write it down, but if we have, yeah, so x is equal to square root of y. So in this case, what we have is x is equal to square root of y, so we would have square root of y here, divided by, so I guess actually let me write this a little differently. So this is not a summation. I did this wrong. Is this going to pull everything? It's going to pull everything. Okay. So since we have the two options, what we're going to do is look at the two options individually. So here we'll look at x is equal to square root of y. So the positive version. So what we have is f of x is equal to square root of y, right? I plug in x for y. And here in this case, if I take the derivative, this derivative is going to be positive. So I end up with positive 2 square root of y. So I can just remove the absolute value here. And then on the other side, I have the other one, right? So I have x is equal to minus square root of y, right? This is my two options. So in other words, here I have f sub x is equal to minus square root of y. And here, since I'm taking I need the absolute value, because in this case, my derivative has a minus sign. So in other words, what we end up having is, well, this becomes positive 2y, 2 square root of y, right? So I can just keep those together. And I have one thing on the coefficient, on the numerator. And that's it. This is what we end up having. And the reason why, so because I didn't tell you what the distribution for x is, this is basically as far as we can go. But this tells me exactly, once I know the distribution of x, I know exactly what the distribution of y is going to be. Once I know the probability density formula for x, I will automatically know the probability density formula of y. And that's it. So we'll stop this video here. And then in the next video, we're going to look at other changes. So in other words, we're taking away all the restrictions and we're going to just see, okay, what happens if I just have some function? What do I do with some arbitrary function? And we'll go there next. So I will see you then.